Okay, Grant. So I've been doing events for a long time, and I think it's always difficult to find really good speakers who are technically minded, programmers, people like that, people who are more comfortable behind the keyboard and away from public speaking. So I'm really grateful that Freddie has kind of indulged me and let me invite him to come along and talk. But yes, next up we have the Chief Technical Officer at Radical Forge and lead coder on the game Southfield. Back in the day, he built out the Blockout Tools plugin for Unity Engine, and I followed him and his partner's progress for a long time back in Middlesbrough. So I'm really proud to see how they've kind of grown as a team, right up to the point where they've kind of transferred, some of the team and expanded into Manchester. So I was really proud to kind of invite them across for today. He's worked on a range of co-dev projects, including their own adorable IP, Brightpaw, which I recommend you download. And he's really passionate about programming tools to accelerate workflows and really empower teams to be the best that they can be. So he's joined us today to talk about how to engineer a co-op, open-world, physics-based farming sim or not. Please welcome Freddie Babord.
Thanks. So, quick bit about me. Freddie, I'm the CTO at Radforge. I've helped ship multiple titles in Unity across my career, from Sub-Level 0 to 10s to Salt Sea Chronicles more recently. I've been using Unity since Unity 4, back in 2013, but professionally since 2016. And I'm a generalist, but I love making tools to help other people. Also, I'm very much a coder, and I've tried to not make this a very dry talk, so apologies if that has come across that way. Quick little bit about Radical Forge. I've just straight up stolen this from our codev deck, but it was set up by myself and Bruce back in 2017, and we work on a variety of titles, a variety of like indie through to AAA titles, such as Jurassic World Aftermath, all the way through to DLC for Zombie Army 4 and Sea of Thieves. We set up based off in Middlesbrough, but most of our staff are around the UK, including myself, who's now just moved to Manchester. Three, tentpole titles I wanted to highlight is Brightpaw, which is our first own IP title, Golf with Your Friends 2, which we announced as co-development end of last year with Team 17, and the focus of this talk is our second own IP title, Southfield. Big caveat to Southfield, it's not actually out yet, so this is kind of like weird timing for a talk. Hopefully, we can share some learnings that we've had over the past couple of years of developing the game. And what better way to intro Southfield than to showcase a trailer? So that's Southfield. We started development back in 2022, and from what we started off with to what we are at now, we've gone through a lot of iteration and a lot of refactoring is probably the lightest way of putting it. We actually started in our pre-production phase. We built the entire game in Unity's new Dots tech stack. So entity component system, burst jobs, a lot of let's say, bleeding edge brand new tech, because we'd hoped that we can get a lot of performance out of scale, because we knew we were going to make a very large object count game. Suffice to say, that lasted as far as vertical slice when we found out that we had teething problems with joints, specifically for the player character. And for a physics-based game, having an issue with joints being a core part is a small problem. So we had about a month for our next milestone deadline. So we rewrote the entire game at that point into normal Unity netcode for game objects and normal game objects. Massive undertaking. Kudos to the engineering team that actually made that happen. And then we kind of like built it up more from there. It went through closed beta, and from closed beta we took on iterative feedback from the community to then release Next Fest a year later. We're still iterating to this day, trying to fine-tune on what makes Southfield great and that chaotic, family-friendly, physicsy fun goodness you can have with your friends. So I'm going to kind of jump around a little bit throughout the talk, but I'm going to start off with scene management. So Southfield is an open world game. It wasn't originally designed to be it wasn't originally an open world game. It kind of stumbled into it. I can remember there was like a few pitch decks where we were going to have a system in place where you'd start off on your farm and then you can catapult yourself with you and your friends over to like another biome or another area. That never made it past the proof of concept paper phase, and we kind of just ended up with, here is a large map, go wild. In our Unity project, we have about 175 Unity scenes that we have to navigate around, which is a lot, which comprises of blockout scenes that we'd actually release to the public, what we call sub-scenes. I know Unity has a different meaning for sub-scenes. Our meaning is any scene that's additively loaded onto a core scene, and dev-only scenes such as playgrounds or art rooms. Managing the large quantity of scenes is a problem, especially if you're trying to switch between different contexts regularly. Like you might want to set up construction pieces in one area, and then you might need to move on to working out how a crop behaves. So you want to be able to swap context very simply. And also, we had about 40 people peak working on the project at the same time, all being an engine. So we needed to make sure that devs didn't clash with each other, because merge conflicts suck. Starting off on the editor side, we imported our version 1 tool of the scene jumper, version 1 iteration of the scene jumper, which is great for Brightboard. Brightboard's super small, and it's very easy to quickly scan through the list of scenes and work out what you want to pick out. Wasn't entirely suitable for Southfield when we actually threw 100+ scenes at it. And there was some things within this tech that we didn't actually end up using, like scene statuses. All of the scenes back there were marked as to do for the entirety of development, including up to when we released the definitive edition 2 years after. And we just never also used scene notes where we could write notes to each other and have them embedded into Unity scenes. We rebuilt it from the ground up now in UI Toolkit. We introduced the concept of favorites. So if you were an artist, most likely you'd be in art rooms a lot more than you would inside any of the mechanic playgrounds. So you could mark scenes that care most to you to surface at the top. And for the first time, you could also now not dock the core window. And when we found out that we could start adding tools next to the Unity play button, we went a little mad and have to make sure that we don't actually clutter the main editor UI anymore, but at least it's very quickly accessible. We're then going to move on to Golf with Your Friends 2, and we're going to put in some of this tooling into that project. And the UI UX on this is okay. It's not the best, but because it's now going into an external client project, and it would be used by people outside of Radical Forge potentially, we decided to clean up the UX a little bit. So the previews got smaller, so instead of like a 1080p image that we'd use, it's now just a 256 image. So it helps with loading all of that content quicker in the editor tool. And we expanded on the favorite system where we introduced the concept of tags, which are both automatic and manual. So on the automatic side, if a scene contains the words, for example, art_room, we could tag it as an art room, and then you can filter by that tag just to help manage the sheer quantity of scenes. We'd want to implement future niceties, I guess, where it's integrated with the Unity settings system, so we can more box off and more box off the tool and make it feel more part of the core engine experience. You can see the iteration of the past 7 years of this small tool that's in use every day. So that's all well and good, but with a large quantity of scenes, we needed a way to manage our scenes in our build pipeline and also be able to swap what we want to do for our in-editor, being able to play the game in editor. This is also built on UI Toolkit. I have a small thing for UI Toolkit because the tech stack is amazing because it's based off web tech, although it's still relatively new. It's trivial to add new scenes to a new scene collection. So our scene collections are groups of scenes to form a releasable, a state of the game that we'd want to play the game in. Be it in this example, this is actually all of the Unity scenes that we load when we want to ship for early access. And we also have other scene lists for stuff like mechanics playgrounds. Needing to turn them off and on, especially when we come closer to launch, we don't really want to manage the build settings window and needing to work out what actual specific scenes need to be enabled. So we just let this tool do it for us, and we just check a checkbox of this entire collection of scenes needs to be enabled for the build pipeline. And it's easy to also swap what scenes you're currently playing in through the left-hand side of the editor toolbar next to our autos button, which I'll talk more about towards the end of the talk. But it's a very quick, simple way to also allow our devs to swap between loading in the entire game map or just loading in a machine's playground. Scale. So with it being an open world game, we have some technical challenges that we haven't previously experienced at the studio. We came from making our first own IP game, Brightport, which is a tiny mobile title, to making a medium, largish scale physics-based sandbox that you can play with your friends. So a massive leap in technical requirements. We were actually recently trying to upgrade the game from Unity 2023.1 to Unity 6, and we found that there were just under 12,000 physically simulated game objects running in the scene at once, which is a little bit too much. We noticed that because of this, in Unity 6 we saw massive performance degradation because of how Unity's changed how physics integration works inside their game. Unity were trying to standardize how their physics engine works. So they have 3 of them. They have NVIDIA Physics, Unity Physics for Dots, and Havoc, and they wanted to try and make them all hot swappable. And in doing that, they changed some APIs and how on triggers were called to the point where even though in Southfield we banned the use of using on-trigger stay inside any of our code base, it was still being magically black box called by the engine. There are ways that we can mitigate Unity magically calling stuff like on-trigger stay by just handling it ourselves. By when an object enters on-trigger enter, we can cache it in our own list and iterate through it however we want to. But we had zero control over this. I've been told by Unity that we get a nice magical checkbox that turns this off. I wait until that's actually released. Keeping on scale, our map is medium-ish, large-ish now. This is only phase 1 of the map with 1 biome and a central monolith hub. So it's 6 kilometers by 5 kilometers long. And you can see, and this map is always loaded regardless of where in the world you are, because you can build your way up to a point where you can see the whole thing, and it's quite a pleasant sight, but it's also a major technical nightmare. And the engine doesn't like loading lots of content, we found. There's an amazing talk, there's an amazing GDC talk back in 2016 from Campo Santo when they were talking about Firewatch on how they used a tool called Sector to split up their working scenes. So their devs can work on different parts of the Firewatch map at the same time. This was a big inspiration to our scene tech, where we can essentially segregate off what collection of sub-scenes are loaded for us. So if, for example, we're working on the Monolith Island, we don't really care about having the entire Pleasant Plains map loaded at edit time. So we can just essentially click a small circle and load in just the Monolith Island. This is great for an editor, but it doesn't really solve our runtime issues because most of our content is dynamic. Every tree that you can see, you can probably chop down. So we can't do neat tricks like baked occlusion culling, which suck. Here's a super quick time demo of loading in a smaller section compared to loading in the entire map in editor. So we can probably go 2 or 3 times loading in smaller subsections than loading in the entire game map. So that's in editor. But there's nothing stopping a player doing something like this, which happened during our Next Fest demo, where they decided it was a great idea to plan, I think it was 200 triangles. Commitment to the player. I don't think I'd have the patience to do this. So to help solve managing runtime data, we had to think a bit more carefully on how we structure scene content and how we structure loading in runtime content. So we came up with a concept called chunking, where we split the game map up into various cells. This piece of tech is still very much in development, but the core premise seems to work and seems to do what we want to do. It's based off an octree map, so the next image will show you exactly the data structure. But it means that we can load in the cell that you're currently in and adjacent cells around each player. And we can tweak how many cells that we want to load in. So you and 3 other players are in the scene, then at a minimum we can load in 4 cells out of the, I think it's 60 to 70 cells we can have active, we can have in the game map. But at worst it can be 36 cells, which is still over half of the content that's not being loaded at runtime. This also solved our issues of wanting to add new biomes in future updates. So we can pre-generate a bunch of the runtime dynamic content, and if objects exist within a cell, then we write the cell's contents to a file, and that's what's shipped. If we decide to add a new biome, for example, to cell 1944 or 2004 in the top right-hand corner of Pleasant Plains, then when we regenerate that default save file, because the player can't naturally get to that boundary because we put blockers there, it means that we don't collide with any content that the player has then built. So it's additive. So they get the new content without affecting their existing save data. So this is if we have the entire game map loaded without the chunking tech that enables or disables cells active. And utilizing an octree in this method means that we can take the bounding volume of anything that's a dynamically spawned object, which is highlighted by any pink bounding volume, map it into an octree, so then our save system can essentially make bounds into that octree to work out what subsection of object IDs it needs to then save out without actually parsing more complex data structures. Cool. So that saves overall content that's further away, but what systems did we have to put in place to make it easier for the game to handle large quantities of items that players will just decide that they want to pile up? Combat this, certain items in our game can be stackable, and to assist with this, if an object is stackable, then there's no reason for an object to not automatically combine with each other. It's super small and super simple, but it means that if we have automation, that means that a player is making 50, 100 seed bags, we don't have to keep tracking 50 or 100 seed bags. They can all combine into one asset. And we can also recycle those objects that are generated and put it back into an object pool. So the seed maker can create a seed bag, plop it on the floor, seed bag processes another one, creates another seed bag, plops it on the floor, but then because the two of the objects then collide with each other and they're below the object stack, that object can then be returned to the object pool and reused literally for the same loop. So we don't actually have to spend the cost of instantiation of the object, destroying it, and having many loose items in the physics world. We then had to also develop an interest management system for Unity. So we don't have tethering in the game. Whether that's a good or a bad thing, up for discussion. But there's nothing stopping a player, any of my friends that join me, going to all 4 corners of the map, and we'd have to load and manage all that content regardless. And that's also a lot of potential network bandwidth that we'd have to contend with. So in the top right, this is a client that's connected to the host that's on the left. The red outline is any of the positions any of the transforms that have been sent by the server. The green outlines is the game client predicting where the transform wants to go the next few frames. When the player runs away from this, I think it's currently like 36 units. When the player runs further than 36 units, the server stops sending transform positions over the network, and instead it falls back to a local simulation. So this way we cut down on network bandwidth. When the players then run closer and hit that 36 meter boundary, they then re-get the more up-to-date network data, and it interpolates back to where the server wants the object to be. I've managed to go 27 slides and not actually talk about Bud, our little, adorable little character. He's just a wobbly boy. So let's change that. So our requirements for Bud is Bud have to have emote support. He had to feel floppy and fun, so he had to be clumsy. And he had to be able to support a variety of states, from walking around to tumbling to curling up into a ball and rolling around the game map. But you also had to feel responsive. Now, our previous games that we've helped work on, such as Gang Beasts, they're a very ragdoll-based game, and the way they do locomotion is it wasn't really animation-driven, which for what we wanted for Southfield, we needed to think about other solves for it, because we wanted Bud to be able to wave to other players, to be able to play rock, paper, scissors with your friends, while still feeling physicsy at its core. So we came up with an active ragdoll system. So we have two skeletons always attached to the character, one that's animated and one that's a complete ragdoll. The animated character drives the ragdoll character, and we can control, based off the player state, whether they're running around, swimming, rolling, how much the animation affects the ragdoll. It will set configurable joint properties on target positions and target rotations, and we control the spring strength on how much it conforms. So we can get away with more heavy physics-based movement that still do animations, but still feel floppy and fun. That's a brief segue into Bud. Google Sheets. So we're a farming game. We have a lot of data and a lot of content. Radforge is primarily a Google Workspace-based studio, so we love our Google Docs, Google Sheets, and Google Slides. Finding a workflow that would utilize our core tech and being able to bring that into our engine experience was important for us. We did have our own localization system, but we abandoned it in favor of Unity localization because we could import and export directly from Google Sheets. So we can have multiple designers and multiple people working on our localization sheet without worrying too much about merge conflicts, because regardless of what happens in engine, we can essentially always have the source of truth in Google Sheets, and it's also easy to export to localization companies. Taking on a similar approach, we built our own credit system. In Brightport, we had issues in keeping our credits up to date because it was a pain to keep the UI updated realistically, because we'd have to manually create new UI objects, expand scroll views, and it's just cumbersome. With this integration with Google Sheets, we can just keep a Google Sheets list updated, and fairly regularly we can keep it updated. Press a button in Engine, it auto-populates a scriptable object, and then the engine then rebuilds a content hierarchy based off that scriptable object data, so we don't really have to touch it. Then we expanded more on this tech in that we also use it for our data balancing. Last I checked, we had about 502 crops, and that includes crop variations. And this is just plants. This isn't also including items that you can pick up, such as resources like logs, stone, etc. So it's a lot of data to manage in Engine. Unity doesn't have nice data table tools without you building it yourself. And I wasn't prepared to build essentially a spreadsheet inside Unity. It's not feasible. Why would we when we can just use something like Google Sheets? So we can go on package repositories such as NuGet to grab the Google Sheets API DLLs, pop them in the engine, and make sure they're editor-only so they don't actually ship with the game, because we don't need players to actually care about Google Sheets. But it means we can do stuff like this, which is just a small snippet of our variables list of crops. So if there was shiny crops, we can make it so then we take their base value and just multiply their amount that you can sell it by 2, for example. And we just apply mathematical equations very easily in Google Sheets and then import that data back into Engine. It's also a lot easier to visualize this than it is looking at like 500 scriptable objects. So it's very easy to spot any outliers. Addressables content. So sticking on the data themes, the other portion of the game where we have a lot of data is our customization system. With customization, we don't care that it's not networked. It doesn't have to be persistent. It just has to exist on disk. Our interactions with the old Unity's addressables tooling was okay, but the UX for it, we thought we could make better, so we did. Like at the top is our version of Unity's addressable system, whereas the bottom version is what Unity default ships with as of 2023. I actually can't remember if this is what it looked like back in 2022 or 2021 LTS, but we felt like it needed to be more streamlined and more easier to understand of how an asset is addressable and where in the addressable system it's stored. Because when we start throwing in hundreds and thousands of assets inside the addressable system, being able to know where it resides was important. To help manage our cosmetic stack, when you actually create a cosmetic item that Bud wears, it needs a scriptable object definition, which contains a unique ID that's globally unique across all cosmetic items. It needs localization to know what the name is of the asset, icon previews, and it needs to be set up with addressables config. So it needs 5 separate steps to make it functional for us, to make it functional at runtime. And expecting an artist to remember to do that correctly and properly each time. Like, I love our art team. I also mildly don't trust that they'll get all the steps right 100% of the time, and that's fine, because we're all human. When they've made a prefab or a material they want to add to the cosmetic system, they can select it inside the project window and click a button that automatically does all these steps. It generates icon previews, sets up with addressables, and populates localization keys ready to import into Google Sheets. This way we can also minimize asset dependencies and minimize what's loaded at runtime accidentally, because there's no point in loading 4 or 5 times the amount of prefabs for a player when you're probably never going to click on that when you're in the customization menu. Icons. So you can see different icons in the game in various places, for example, inside our almanac or inside the hotbar or inventory system. Needing to generate icons suck, especially in ways that are consistent from what we found in previous projects. So we built a tool called HoloDrone, where we can essentially keep a reference to the prefab, and it updates based off the settings that we give it and the diorama that we give it, what the icon is. And we can just duplicate that config and apply it across all the same categories of objects. This way it's consistent across all 200, 300, 400 different assets that we can have in game. Procedural assets. This is another part of our new tool stack. It's actually a weird name considering it's not actually procedural. This is our asset-based gradient system. So artists can define gradients with schemas, and those gradients can then be applied in materials. We have a painting system in the game, and taking a crop and making a paintbrush from that crop and being then able to apply that paint to a building piece in a network environment, we didn't want to manage colors over the network, and then we also didn't want to manage gradients, which are just more complex. So instead, we can use these gradients to instead send over an ID of where in a global gradient texture it exists. Each of our core categories, so crops, animals, and buildings, all have their own gradient atlas. And they all have slight variations on what gradients exist within them, so we can make the gradients pleasing for that category. So we can have birch as a gradient, but birch for an animal, or birch for a crop, or birch for a construction piece will look ever so slightly different. But we can still use a lookup table, such as the one in the bottom left, and group gradients together. It does also mean that we can also have large-scale atlases. So we can have, in this example, 512 gradients. So we can have essentially 512 different colored crops, all in one texture. And because it's in one texture, it's more efficient for GPU usage, because as we don't need to keep cycling out textures in GPU memory, it makes the render loop happier. Keeping on atlasing, There's another tech that we developed called Packbook, which automatically atlases our runtime, or automatically atlases our texture data. It means that say we could view all 500 crops on screen. That's a lot of unique text. That's a lot of unique textures potentially that we'd have to chuck through Unity's render pipeline. Which Unity's render pipeline is great, but it doesn't do great at scale if it's not configured correctly. We needed to also be integrated with our existing tools. So we currently use Shader Graph and Amplify Shader Editor. So we had to build a custom integration nodes to be able to support this new data type, because we couldn't just import the raw texture into our shader if it wanted to go through Packbook. So after we've marked an asset essentially as a Packbook texture, it would then generate an atlas similar to these two, where there's space for us to grow into, but it's also one texture instead for all crops, which is more efficient to render. So that's how we helped manage rendering at scale. That's one of the ways we've helped rendering at scale. Auto-host, so I guess I'm kind of like getting to the end of it a little bit. And I've darted around a lot on like all the tools that we've helped build and develop internally. But we used to have a dedicated server as our networking architecture, which sucks when you're trying to do anything in editor iteratively and quickly. We'd have to kick you back to the main menu, do a bunch of online networking setup, and then actually kick you into gameplay. And the play button just didn't have enough fine-grained control. Unity's play button didn't have enough fine-grained control for us to be able to do all the setup that we needed to do. So we built our own, essentially, and stuck it next to the play button. You can see that there's like server-only and client-only there, and that is remnants of when we were definitely a dedicated server-based game before we moved to client peer-to-peer networks. And that change was allowed to happen because we dropped the requirements of needing to utilize systems such as what we dubbed the farming pass in the early days, which is essentially just a battle pass, but that got axed, so we could axe the need to use a dedicated server to more consistently track what players are doing. We still can use client only though, because we use tools like Parallel Sync, where we can spin up multiple editors at the same time on the same machine, and when they click auto host, it can connect to the host editor. So it's easier to test multiplayer. This is also where we go back to scene lists, where it was easier to stick it next to the main play button that we're going to be using to want to jump to, I now want to load the entire game map that a user would experience. So that will be the 07 EA launch scene list. Or I'm now focusing on I found a bug on how NPCs are being handled, so I need to just focus in on NPCs. I don't care about loading the entire game map. So we can just load in now our MC testing scene, which is a separate collection of subscenes. Some honorable mentions of some tech that I'm not going to touch on, but helped us a ton, is Unity's virtual texturing solution, which is great for needing to render many different biomes. This helped us render many different biomes in our stress tests, effectively without needing to manage large texture stacks, because each of our terrain tiles could have either 16 or 32 textures, which I can't remember off the top of my head. Pooling systems for fmod, so we can reuse and limit the amount of audio objects that exist in this game, because there's nothing stopping a player plopping down 50 conveyor belts within earshot, and realistically, you're not going to tell the difference between hearing 2 or 3 conveyor belt audio sources than hearing 50 of them. We utilize A-Star Pathfinding project, so it's burst-driven AI pathfinding navigation, and some other useful tech, such as GPU occlusion culling in Unity 6, and Unity Relay for cross-platform multiplayer relay service, so we don't have to. So it's easier to connect to other players just by either an invite code, without having to deal with IP addresses. Other back-end infrastructure, such as Loot Locker, which helps us with Twitch drops and also gifting cosmetics to players regardless of their accounts. Also, big shout out to like the engineering team that has built the multitude of wizards, like small wizards that exist within our game, such as the construction wizard that allows designers to just click like 9 squares and work out, this is the recipe that this wall needs to make, in a very like Minecraft crafting block style visual. Just makes it way easier to use than needing to drag 9 different references to various scriptable objects. that's a whistle-stop tour on Southfield's tech and how we kind of built and managed large scales for our first medium-scale internal title. So it's a big jump from our previous one, but it's been a fun adventure. And hopefully, when it releases, it will actually live up to expectations that various people in the industry have. Thanks.
Awesome. So I always kind of love talks that make me feel a bit stupid, so that was brilliant. Has anyone got any questions? Yeah.
Hi, I'm Jasper, and I'm an aspiring games programmer. How did you deal with version control in Unity?
So in Unity, we use Git. We have our own GitLab server. Everyone has their own, essentially, feature branches that they work on. They then submit a merge request, which then runs through our CI/CD pipeline, so that it runs through automated build pipelines to make sure that the game doesn't break. And then when they pass, and if it contains code, the code is reviewed. It then gets merged into master, and then it's available to us with the dev team.
Do you have any tools for resolving scene mergers?
Not really. For our scene merges, we just try to communicate on what scenes the rest of the dev team are actively in. Specifically for Southfield, none of this, we don't do anything like file locking, which exists in Perforce, which we do for some of our other titles, like Golf with Your Friends. But with Git, it's just a case of communication with the team to make sure that we don't trip up over each other.
Thank you. Your game looks very good.
Thanks.
Anyone else? Yeah.
Hi, I'm Swaber. Oh, sorry. I'm Swaber. I'm a games programmer as well. I wanted to ask, the tools that you made, specifically like the ones that you used using the UI toolkit, were those tools made sort of as and when you needed them or towards the start of the project? And if you looked back retrospectively, what would you recommend doing?
So a bunch of these tools were made throughout the project. In an ideal world, we would have done our jobs properly, or I would have done my job properly and identified the requirements for all of these tools in pre-production, and would have made all of this tech in pre-production. But the nature of our internal development pipelines is it's not entirely obvious what we need to make in the initial steps of making a game. So we kind of had to, I guess, wing it. And when we noticed that there was an actual time sink issue in what our devs were facing, that was the catalyst at the point of like, maybe this requires a different way of approaching it. Maybe this does require a tool.
What made you choose the chunking system that you implemented with using the octree over other methods of like loading and optimizing things?
With the restrictions that we had in how we could or couldn't have game data loaded, we couldn't just have static objects existing in the scene and have them exist within scene files themselves, just because of how dynamic the game is. Like, there's nothing stopping a player chopping down every tree that exists and replanting them in different places. When we were evaluating different ways of solving this, one of the easiest solves to the sheer object count issue, because it is just an object count issue at the end of the day, because we're trying to throw too much at the render pipeline or trying to throw too much at the physics engine, is let's just remove objects. So the natural segue to that is just let's split the game map up into blocks that make sense, be it like split up the map into 4 or split up the map into 8. And then after speaking with Unity, we had some back and forth on like suitable approaches on how we could best optimize this as a problem. And they also actually suggested an octree-based system, which essentially just tracks positions, because all we actually care about is positions. And a quick and efficient way of segregating out cells is, instead of just having, for example, like a list of bounding volumes, which then also contain a dictionary of bounding volumes, which contain a list of every object that exists within those bounding volumes. Octrees are just way more performant, we found.
Okay, thank you very much. Your talk was really good as well.
Thanks.
Thank you.
Hi, Natasha Handley from Leeds Beckett. It's an incredible amount of engine customization has gone into this game. And did you say you went from Unity 2021 to Unity 6? Was that just directly from one to the other?
So we've not actually moved to Unity 6 yet, mainly because of the physics changes that Unity performed when they released Unity 6. So we're currently still stuck on Unity 2023.1.20. So it's not even like an LTS version, it's a text stream version, so whoops. We do plan to move to Unity 6 when we get that magical checkbox. And from all of our other internal testing for Unity 6, the physics issue that we've encountered so far is the only issue that we've uncovered. Everything else seemed to have just upgraded fine.
Okay, that's interesting because I was wondering how well the tools migrated from 2021 to Unity 6, or whether there would be any challenges in developing tools for Unity 6 versus earlier versions, whether there's any difference there.
Not really. Most of our more recent tooling is now based in UI Toolkit, and because it's based in UI Toolkit, it's the preferred way of making editor tooling going forward. There's not that much of an API change between 2023.1 and Unity 6, considering Unity 6 was supposed to be before they rebranded it Unity 6, it was supposed to be the 2023 LTS. So the actual core engine shouldn't have changed much, but we don't do anything whack, is the easiest way I can probably describe it. We don't do any like weird black magic voodoo that would require us to have challenges in needing to upgrade our tooling.
I'm more of kind of a 3D artist, so like LODs, is that all default, like just in Unity, or did you implement a system for that?
So we do use Unity's LOD system to help with the sheer quantity of objects that we needed that our art team needed to LOD. Unity doesn't have yet an inbuilt automatic LOD system, such as like the Unreal does. It's coming, so we've seen.
Cool.
So instead of having an artist needing to manually make an LOD in Max or Maya and then re-import it into an engine, we use a piece of tech called Instalod, where we have preset configurations on what each LOD should roughly be, and then batch import and export from the engine.
Oh, okay, that's cool. And I'm guessing draw calls as well. Is that just the instancing within Unity? Or
Yeah,
just same again.
we make use of the scriptable render batcher, for one, and we also try to minimize the workload on the GPU by ensuring that as many objects share the same textures, hence why Packbook exists,
as well.
or trying to make sure that we have one master material for every crop so then they can be rendered in as few draw calls as possible.
Yeah. Oh, perfect. Thank you.
So I've got a question. I think you've done talks at Unity before. Like, what is your relationship with Unity as a kind of developer? Like, do you have input with them about the tools that you're developing, or like, how does that relationship work? Do they give you advance notice, or what is that kind of support relationship like?
Oh, sorry, I just chuckled at that one. Only because last time I spoke at Unity in their Brighton offices, I essentially gave them a tech roast inside their offices. We have a really good relationship with Unity. Like, we tell them what all the active Unity projects we're working on. They tell us all the cool and interesting new tech that's coming up inside the engine. We also have a say in how that tech evolves. We get invited to closed sessions where they showcase some new what they want to do with the engine going forward, such as their new animation package or the new world building tools that are coming up. Try to have direct feedback on that tech, which we know we're not going to be able to use for a year, 2 years, 3 years. But we know that when we get to that stage, we want to make sure that what exists at that point would be suitable for our usage.
Awesome. So I'll kind of leave it there. So big round of applause for Freddie.